Good morning, everybody. Today we are going to do time value of money. Time value of money. So in this session, we don't have any handouts. I will explain everything on the board today. So you have to follow it very carefully. Right. What is the meaning of time value of money? This is 100 rupee note. Everybody knows. This is 100 rupee note. So we call it face value of the money. This is face value of the money. Okay. So today, now we let us say this year, year 2020. Last year, 2019. Before that, 2018. It goes on like that. Next year, it will be 2021, 2022. It will go on like this. So now it is 200 rupees. Last year also it is 100 rupees. Before that also it is 100 rupees. Next year also it is 100 rupees. So always it is going to be 100 rupees. We call it face value of money. Face value of money. 100 rupees. With this 100 rupees, now a pound of bread is 60 rupees, 65 rupees. So we can buy about 1.5 pounds of bread now with this 100 rupees. In 2018, a pound of bread was 50 rupees. So we would have bought about 2 pounds of bread. So now we can buy 1.5 pounds of bread, which is 100 rupees. In 2018, it was around 50 rupees a pound of bread, so we would have bought 20. Maybe next year, or in 2022, for 100 rupees, we may buy about 1 pound of bread. 1 pound of bread, we may buy. So what is happening for this 100 rupees? The purchasing value is getting diminished. The purchasing value is getting diminished. So we call it purchasing value or real value of money. So we can say when the face value of the money remains unchanged, the purchasing value of money or the real value of money is getting diminished over a period of years. Once again, by doing this analysis, there are two values for the money. One is the face value of the money. Other one is the real value or the purchasing value of the money. So we can say when the real value of the money, when the face value of the money remains unchanged, that is 100 rupees always. The purchasing value or the real value of the money is getting diminished over a period of time. This may be due to inflation and various other economic factors. So this is we call as time value of money. So this is time value of money. So in other words, there is a proverb, a bird in the hand is worthier than two in the bush. A bird in the hand is worthier than two in the bush. The money what we have today is worthier then the same amount of money we may receive in a future date. The money what we have in our hand today, the 100 rupees I am having now, it is worthier than the 100 rupees I may receive in a future date, because the real value of money or the purchasing value of money is getting diminished. So this is time value of money. So once again, the money what we have today in our hand is worthier than the same amount of money we may receive at a future date. This is time value of money. So when there is a question, briefly explain time value of money, you must say all these things with a suitable example. With a suitable example. So this is time value of money. I hope it is clear to everyone. Time value of money. Sorry? Right, I will use right. Well, so having explained that, let us move on. Now I am today, that is 2020, I am having 1 rupee with me, 1 rupee. Then it will be 2021, 2022, 2023, 2024, it goes on. So in other words, now we call it year 0. Now this is year 1, this is year 2, this is year 3, year 4 goes on. Now 2020, now today, so whenever we call it year 0. From 12 months after that, year 1. So on, after 12 months, year 2, this goes on like that. Now we call it year 0. So in the year 0, we are having 1 rupee with us. I want to invest this 1 rupee on a fixed deposit, let us assume, with automatic renewal. In a fixed deposit with automatic renewal. So interest rate, say 12% per annum. 12% per annum. Interest rate. At an interest rate of 12% per annum. So 12% per annum means 400 rupees, 12%. For 1 rupee, it is going to be 0.12, not 0.12. The interest for 1 rupee, it will be 0.12. 12% per annum, that means 400 rupees, 12 rupees interest. So 1 rupee, it will be 0.12. So now, I told you I am having 1 rupee now. I am investing that with a bank in a fixed deposit with automatic renewal. Automatic renewal in the sense, every year interest will add on to the capital. And that amount will earn interest for the following year. Every year, interest earned will be added to the capital. So now, 1 rupee. So next year, it will be 1 plus 0.12. Is 1 rupee, we learn an interest of 0.12 and it will add 1 plus 0.12. In the following year, next year, year 2, what will happen? This is going to be the capital and this capital will earn interest. So 1 plus 0.12, this is the capital, plus interest on this capital. Interest on this capital. That will be 1 plus 0.12 into 0.12. This is the capital portion. This is the interest portion. So in the second year, the first year 1 is going to be the capital, that is 1 plus 0.12 is the capital, that is going to earn interest. So that interest will be 1 plus 0.12 into 0.12. If you put 100, if you do it, you will get this amount. This is the interest. So this is the amount total. You will have it in the year second, year 2. Now, simple mathematics, which you would have learned in your 4th grade or 5th grade, 5th standard. So here, this is a common factor. 1 plus 0.12 here and here is a common factor. So factorization, you can take that one out. And you must remember, if there is 1, before this bracket, if there is 1 into, you say 1 into, it is same. If there is 1, it is going to be same, 1 multiplied, so it is going to be same. If there is 2, it is different. If there is 1, it is same. So now you are taking factorization, taking the common factor out. 1 plus 0.12 taking out. If you take out, here also you are taking, here also you are taking. Here you left with 1, plus, then you take 0.12. Here it is. You are taking 1 plus 0.12 out. So when you take this one out, 1 plus 0.12, 1 plus 0.12. So this is going to be 1 plus 0.12 to the power 2. So what will happen in the year 3? Year 3. This is going to be the capital. This is going to be the capital and this is going to earn the interest. So 1 plus 0.12 to the power 2. This is the capital portion, plus this is going to earn interest. The interest portion, 1 plus 0.12 to the power 2 into 0.12. That is the interest. So this is the capital portion. This is the interest portion. Again, factorization, take 1 plus 0.12 out, 1 plus 0.12 out. So when you take this one, you take this one, this is the common factor, 1 plus 0.12 to the power 2 is a common factor, you take that one out. So into here, as I said, 1 will be there, 1 plus, when you take it out, 0.12. So this is equal to 1 plus 0.12 to the power 3. 1 plus 0.12 to the power 2 into 1 plus 0.12. This is 3. Third year is 1 rupee the value of the 1 rupee will be 1 plus 0.12 to the power 3 in the third year. What will happen in the fourth year? Year 4. This is going to earn interest now. This is going to earn interest. 1 plus 0.12 to the power 3. This is the capital portion. Plus, this is going to earn interest at the rate of 0.12. So 1 plus 0.12 to the power 3 into 0.12. So this is the interest portion. When you simplify this one, 1 plus, when you factorize this one, 1 plus 0.12 to the power 3, then into, when you take it out, automatically there is 1. So 1 plus 0.1. This is going to be 1 plus 0.12 to the power 4. In the fourth year, but I have 1 rupee today. Now, the value of that one will be 1 plus 0.12 to the power 4. So if you take the nth year, any year, I repeat, when it is coming to second year, 2 year, the value of 1 rupee will be 1 plus 0.12 to the power 2. When it is coming to third year, present 1 rupee will be, the value will be 1 plus 0.12 to the power 3. In the fourth year, it will be 1 plus 0.12 to the power 4. So in the nth year, I will write it. Okay. In the nth year, I will erase a portion of this one and write it. Or otherwise, here I will write it. In the nth year, this will be 1 plus 0.12 to the power n. In the nth year, the present 1 rupee at an interest rate of 0.12 or otherwise 12% per annum, right? When you convert it to decimal, it is 0.12 at the rate of 0.12 interest rate. The value of present 1 rupee at the nth year will be 1 plus 0.12 to the power n. Okay? Yes. We call this 1 rupee is the present value. So it is called as present value of the money. Simply we call it PV, present value of the money. The value of the money in the future years or future dates, we call it future value. Future value. In the future dates, we call it future value. So the money what we have today is the value of the money what we have today. We call it as present value, PV. The money we will get in the future, we call it future value of the money. Call it FV, future value of money. So now we have learned 3 things. One is time value of money, and the other one, present value of money. That is what the money what we have today. It's the present value of the money, and the future value of the money we receive in a future date. Future value of the money. All these are future value of the money. This is the future value of the money in the year 1. This is future value of the money in the year 2. This is the future value of the money in the year 3. this is the future value of the money in the year 4. So in the nth year, that will be 1 plus 0.12 to the power n. In the nth year, the future value of the money is. This is for 1 rupee. This is for 1 rupee. Present value, what we have, 1 rupee. This calculation for 1 rupee. So we can write like this. One plus 0.12 to the power n. So this is when the present value is equal to 1, then when the present value is 1, the future value is this. So when the present value of money is 1, the future value is this. So this is future value. When PV is equal to 1. When PV is equal to 1, the future value. So if this is the interest rate in decimal. So if the interest rate is R, this will be equal to 1 plus R to the power n. If the interest rate is R, the future value of present 1 rupee will be 1 plus R to the power n, where R is the interest rate in decimal, n is the number of years. R, interest rate in decimal, and n is number of years. That is the yes. This is for 1 rupee. When PV is 1 rupee. So when the PV is 100 rupees, what will happen? FE is equal to, this is for 1 rupee, this is for 1 rupee. If the PV is 100 rupees, the present value we have 100 rupees, then 100 into 1 plus R to the power n. When PV is 100. So instead of 100, if we say whatever the present value, we can say FE is equal to PV. You multiply by the present value into 1 plus R to the power n. This is the formula we are using to convert present value into the future value. This is the formula we use to convert the present value to the future value. So we have worked out. First we worked out for 1 rupee. Calculate the future value for present 1 rupee. So from that one we have developed. So if the present value is 100 rupees or 1000 rupees, 1 lakh here. Multiply by that amount, so equal P. So future value is equal to present value into 1 plus R to the power n. Where R is the interest rate in decimal, n is the number of years. This is the formula. So this is a technique converting present value to the future value by using this formula. There is a term for this technique. We call it compounding. Now another term we are learning now, compounding. Now, in the time value of money, we are learning another term. It is compounding. Please, if you want, you can take it down. Compounding is a technique converting present value to the future value. Compounding is a technique converting present value of the money to the future value. That is compounding. And this formula is called as compounding formula. Compounding formula.
Excuse me, sir.
Depending on the present value of the money and the interest rate and on the number of years. Once again, the future value of the money depending on present value of the money and the interest rate and the number of years. So if it is 1 rupee, present value is 1 rupee. If the present value is 1 rupee, then it depends on the interest rate and the number of years. So, when the present value of 1 rupee, the future value, we call it as the future value of the money. When the present value of money is 1 rupee, the future value of the money, there is a term, we call it as compounding factor. Compounding factor. So what is compounding factor? If anybody asks, you know compounding, then what is compounding factor? That means when the present value of the money is 1 rupee, the future value of the money at various interest rates and at various number of years is called as compounding factor. And you will get numerous compounding factors depending on the interest rates and on the number of years. So compounding factor, you will get various depending on the interest rates, maybe 1%, 1.1%, 1.2%, 1.3%, 1.4%, go on, and 2%, 2.1, 2.2, then go on 3%, 3.1, 3.2, go on 4%, like that. For each percentage interest rate, and for each year, you will get different compounding factor. So there is a compounding table. There is a compounding table. There is a compounding table. Like log table, logarithms, you would have learned mathematics, log table. For trigonometric, when you have learned, there are sine table, tangent table, cosine table, cosec table. There are, yes, like that. Compounding table. So in the compounding table, the compounding factors are given. Compounding factors are given for number of years, 1 year, 2 years, 3 years, 4 years, like that, and for different interest rates. Different interest rates. There are compounding factors are given. Compounding factors are given. So that is compounding table. So by using that compounding table, you can get the compounding factor for various interest rates, for various periods, and convert. So if you know the compounding factor and convert the present value into the future value, you can convert present value into future value. Okay. I hope up to now it may be clear to you all. I am raising this. This is compound. Right. Now this is a simple calculator. I want to say something about this calculator. Right. This is simple calculator, you all know. In a calculator, you put input 5, then multiplication sign, and then 2. You will get 10. 5 into 2, you will get 10. Okay, then 5 into 2, you will get 10. Then you just press equal sign, you get 50. Equal sign, you get 50. Again press equal sign, you get 250. What is happening? When you put 5 input into 2, equal sign, you are getting 10. So without putting anything, you are just pressing the equal sign, you are getting 50. Again equal sign, you are getting 250. That is, this answer, what you got, this answer, what get multiplied by the 5, the first input. Then again, this answer get multiplied by the first input, 5. Again, if you press, it will be 250 into 5, 1,250 you will get. 1,250 you get. Again, 6,250 you will get. So this facility is there in this computer, in this calculator. Some of the calculators, when you press equal, it will multiply this way. What will happen? Not this calculator, there may be some calculator. What happened? This answer 10, then multiply by the second input, 2, 20. Again equal sign, 40. Again equal sign, 80. Again equal sign, 160. It goes on like that. So the calculator, the simple calculator, there are factors like that. So first you must find out. So first input or second input will get multiplied. The answer will get multiplied by the first input or the second input. So if you find out, then you can use it for our calculations. This is the facility we have in the simple calculator. Right. So why I am saying this, I will do. A customer is coming to you. He says, sir, I want to keep 5,000 rupees at your bank in a fixed deposit. 5,000 rupees at your bank in a fixed deposit. So what is the interest rate you will provide? Okay, maybe 14%. If I keep it for 5 years, how much I will get? If I keep it for 5 years, how much I will get? Okay. So that's a simple way. That is, he is asking for the future value of this money. Future value of the present value of 5,000 rupees. How much will be the future value at the rate of 14% per annum at the end of the 5th year from today? So future value is equal to PV into 1 plus R to the power n. You know that. So here, so what you can do, you can use the compounding table also. Compounding table. First, you find out for 1 rupee. So 1 rupee. So you calculate this one. This is for 1 rupee. This portion. This is the compounding factor. Compounding factor. This portion. So go to the compounding table. What is the interest rate? What is the period? See what is the compounding factor? You know this one. Then multiply by the PV into compounding factor. That is PV is equal to 5,000 into compounding factor. From the compounding table, you take the compounding factor and multiply by 5,000. That is going to be the future value of the present value of 5,000 rupees by using the compounding table. From the compounding table, you calculate the compounding factor and do it. Okay. But without the compounding factor, you don't have the compounding factor. So what we can do? So is equal to PV into 1 plus 0.14, that is the interest rate in decimal, into 5 into n, that is number of years, to the power 5. So this is equal to PV into 1 plus 0.14 into 1 plus 0.14 into 1 plus 0.14 into 1 plus 0.14 into how many times? 1, 2, 3, 4 into 1 plus 0.14. This again PV is into 1 plus 0.14, 1.14 into 1.14 into 1.14 into 1.14 into 1.14. 1, 2, 3, 4, 5. So 1.14 you are multiplying up to 5 times. 1 plus 1, 4 you are multiplying. So we use the calculator. Clear? 1.14 into 1.14 2 times equal. Then again what I am going to do? Again multiply. So 2 times finish, equal sign 3rd time, equal sign 4th time, equal time 5th time. So it is 1.19, 1.9250, so many decimal. So it's equal to PV into 1.925, 3 decimal we have taken. So this is the compounding factor. This portion is the compounding factor. This portion is the compounding factor. This answer you would have obtained from the compounding table. So instead of compounding table, by using this simple calculator, we are calculating it. 1.125. So into is equal to PV is now 5,000 rupees. He is going to deposit into 1.925. This is equal to 5,000 into 1.95. 9,750. So after 5 years, that customer will get, the customer who is depositing 5,000 with you at your bank at an interest rate of 14% per annum will get 9,750 at the end of 5th year from today with automatic renewal. With automatic renewal. So the present value is 5,000. The future value at the end of 5th year from today at an interest rate of 14% per annum, it is the future value 9,750. So when a customer actually when come to you asking about the fixed deposit rates and various things and say, I want to deposit about 1 million rupees with automatic renewal for a period of say 3 or 4 years, then you can simply take your calculator. If you ask how much I will get at the end of 3rd or 4th year, so by using this simple calculator, you can calculate and tell him. You no need to say system is down. I am unable to tell you, find out. System is down. Please come tomorrow. No. With a simple calculator, you can tell. Even the computer is not necessary to you to do this calculation. Even somebody come to you casually asking you at your home also, you can take the simple calculator and tell this. Right. So let us do another exercise on this one. Now I hope this is very clear to you. This is compound. So now you understand time value of money, the meaning of present value, the money what you have today, the meaning of future value, the money what you will receive in a future date, and then the term compounding, the technique converting present value into the future value, compounding table, compounding factor. When the present value is 1 rupee, the future value at various interest rates and various periods is called as the compounding factor. So all these things you know now. Compounding factor. Yeah. Okay, I will erase this. We do another simple exercise. The present value 8,000. Interest rate 13% per annum. Number of years, say, 6 years. What is the future value? Please do on your own. I will give you a few minutes. Please do it. Future value is equal to our formula, compounding formula, PV into 1 plus R to the power n. This is the compounding formula. Equal to PV, 8,000 rupees. 1 plus R 0.13 and is 6. So this is going to be the compounding factor. This you can calculate, you can get it from the compounding table, or you can calculate. This is equal to 8,000 into, I simplify this one, 1.13 to the power 6. So this is equal to 8000 into 1.13 into 1.13 into 1.13 into 1.13 into 1.13 into 1.13. This is the compounding factor. At the 6th year, at an interest rate of 13%, the compounding factor. 1.13 into 1.13, 1, 2, 3, 4, 5, 6, 6 years. So take the calculator, clear? 1.13, 1 year, one time into 1.13, 2 times, equal sign 2 times. So go up to 6 times. 2, 3, 4, 5, 6. So this is equal to 8,000 into 2.0819. So I make it as 2. 2.0819 you are getting, and so on. It's like that. So 3 decimal, so 2.0. So this is equal to 3,000 into 2.082 equal 16,656. The future value 16,656. So converting the present value into the future value of money. One thing, when you increase the number of decimals, your accuracy of the answer will increase. Your accuracy of the answer will increase. Really, when you are doing this one with the computer, the more accurate answer you will get. And compounding table also, the number of decimal depending on the number of decimal. Yeah. So when you do like this, so at least you have to take at least 3 decimals. At least 3 decimals. When you go for 4 decimal, then you may get something different answer. Something, not a big difference, small difference will be there in the answer. So in our calculations, better when you do exams, when there are any problems like this, when we ask, use the calculator and do this calculation, better go for 3 decimals. Better go for 3 decimals. In our papers, sometimes some other papers, they give the, what is the compounding factor. Similarly, later we are going to learn discounting factor. What is the discounting factor? They will give, this is the discounting factor. So use those discounting factors. Since they are giving, use those discounting factors. So this is compounding. Converting present value into future value. I will erase it. Now, I have told you, the money what we have today in our hand is worthier than the money, the same amount of money we may receive at a future date. Once again, the money what we have today in our hand is worthier than the money we may receive, the same amount of money we may receive at a future date. Because the present value of the money is worthier because it has higher purchasing value, real value. Yes, higher purchasing value or the real value. Now, in projects, when we do projects, what we do, we project the income. We project the income. So now we say year 0 is now. We are investing some money. Then doing the investment, some projects or some business or whatever we invest in. Here we are investing some money. And the year 1, then year 2, year 3 is go on, or year 4 go on. We may get money, income. So these values we are putting in the present value. This much we are investing and we are going to get this much money. We are putting this much of money, we are getting in future, we are going to this much of money. So we must see this is the present value, these are the future values. These are the future values. Whether what we are getting this money in future, whether this money is really worthier than the present money. Present we are investing this much. In future we are going to get. We are going to get this much of money in future. Presently we are calculating and we are projecting. In future we are going to get this money. Whether this money, what we are getting this money in future is more than the present value of money. Whether it is worthier. Whether it is worthier. If it is worthier only, we can go for this project. If it is not worthy, no point in going for the project. It is a loss. So we are making projections, you know, in the bank, the various projects and other things in the customers, we are making the projection. Projection means in future they are going to get that money. So whether that value of money is worthier than the present. So what we have to do, these are the future value of money. This money we have to bring to the present value. These are the future values. We have to bring it to the present value and see. Total it. See whether this total is more than this total. But we have invested. Once again, you are now investing some money. Present value of the money. Maybe 5 million or 6 million you are investing now. In the first year, you are getting 2 million. Third year, you are getting 3 million. So on like that. You are getting some money. Oh, yes. This money is more than this, what we are investing now. But it is not true. You must see whether this future values, you have to convert it into the present value. The future values, what you are going to get in future date, you must convert that one to the present value. And see whether the total of this present value, what you are earning, is more than the present value of what you have invested. Then it is worthier. If it is not more or if it is less than what you have invested, then it is not worthier. So you have to do this analysis. in the project investment analysis. Project investment analysis, you have to do this. So this technique, what we have learned earlier, converting present value to the future value is compounding. Now converting future value to the present value. This is discounting. Now you have to do another technique, discounting. So what is discounting? Discounting is a technique converting future value of money to present value. Converting future value of money to present value. Compounding is a technique converting future value of money to the present value. Converting. So compounding and discounting goes in opposite directions. Compounding, converting present value to the future value. Discounting, converting future value to the present value. How to do it? How to do it? Compounding formula, but we have derived compounding formula. F is equal to PV into 1 plus R to the power n. This is the compounding formula. From use this formula, we make the PV as the capital. Take the PV. So PV is equal to, bring this one here, so this will come down. Fe divided by 1 plus R to the power n. So this is equal to Fe into 1 divided by 1 plus R to the power n. So PV is equal to present value is equal to future value divided by 1 plus R to the power n. So this, of course, we can simply write is take Fe and 1 instead of that one here, 1 is automatically there. It won't make any mistake, it won't make any difference. So Fe into 1 divided by 1 plus R to the power n. What may be this portion? What is this portion? What is this portion? 1 divided by 1 plus R to the power n. Okay. I'm writing here this one. If is equal to PV, if the PV is 1 into 1 plus R to the power n. R to the power n. Yes. So what is this portion then? If it is 1, what is this portion? If the PV is 1, little while ago we have learned PV is 1. What is this portion? This is compounding factor. We have learned compounding factor. So here this is 1 divided by 1 plus r to the power n. This is discounting factor. Discounting factor. So what? So when you convert future value into present value, you calculate the discounting factor and multiply that discounting factor by the future value. So you will get the present value. So this is the discounting factor, 1 divided by 1 plus r to the power n. This portion is the discounting factor. So converting the future value into present value, as I told you, like the compounding factor table, there is discounting table also. Discounting factor table is there, like the compounding table. So the discounting factor also differs for each percentage of interest, and for different years, the discounting factor also differs. For various interest rates, for various period, discounting factor will differ. So in the discounting table, for various period, for various interest, discounting factor is given. So from that one, you take the discounting factor and divide and multiply that for future value. Multiply the future value. You get the present value. So when in some calculation, they will give you the discounting factor. So by using the discounting factor, you multiply the future value and convert that one into present value, and convert that one into present value. Okay, yes. So now how, but which way we are going to do it? We will, let us see which way we are going to do it. So once again, from the compounding formula, we convert that one into discounting formula. We make the PV as the capital, and then automatically this will come down below the FV divided by 1 plus r to the power n. So this portion, we say this is FV into 1 divided by 1 plus r to the power n. 1 divided by 1 plus r to the power n. This 1 divided by 1 plus r to the power n is the discounting factor. So you calculate the discounting factor and then multiply the 11th future value by the discounting factor. You convert into present value. So from the discounting table, so what is the interest rate and what is the period, you can find out the discounting factor and then multiply the 11th future value. You get it, the present value. You get the present value. So this is the way you convert the future value into present value. This is the way you convert the future value into present value. Okay. Now, discounting formula also. So now you know the meaning of discounting. A technique converting the future value into the present value. The meaning of discounting. The meaning of discounting factor. Meaning of discounting factor. That is, when the future value is 1 rupee, for various interest rates and for various periods, the present value is called as a discounting factor. So this is a PV for various values. If this is so, if it is 1, if the future value is 1, the future value is 1. So this is equal to PV. When the future value is 1, this is equal to PV. So discounting factor is the present value for 1 rupee of future value at various interest rates and at various periods. The FE is 1. If the FE is 1, then the PV is equal to 1 divided by 1 plus r to the power n, that is the discounting factor. So the discounting factor is the present value of future 1 rupee. Present value of future 1 rupee at various interest rates and at various periods. That is discounting factor. So now you know the meaning of discounting, the meaning of discounting factor. And the rate, the interest rate applicable in discounting is called as discounting rate. So I'm tracing this. When we learn in compounding, table, we have learned compounding factor, we have learned compounding rate, that is the interest applicable. The interest rate applicable in compounding is the compounding rate. In compounding factor, that is when the PV is 1, the value of the compounding future value, the value of future value, when the PV present value is 1 at various periods and various interest rates, that is compounding factor. In the compounding table I have told you, compound. Similarly, discounting. Discounting table, discounting factor, and discounting rate. Discounting rate is the interest rate applicable. In the technique of discounting, is the discounting rate. The discounting factor, the present value of future 1 rupee. The present value of future 1 rupee at various interest rates and various periods. That is discounting factor. So calculate the discounting factor and multiply the future value. Then you will convert that one into present value. So discounting table, the discount. In addition, I have already told you present value, meaning of present value, then meaning of future value. These are all theory part of this time value of money and the time value of money. Present value, future value, time value of money, compounding, compounding table, compounding factor, compounding rate, then discounting, discounting table, discounting factor, discounting rate. Discounting rate is the interest rate applicable in the technique of discounting. So these are the terms we have learned up to now. I'm raising it. Some questions have been given to you. Yes, you would have received it, I think. Take the third question of it. Please read it. Take the third question. We have sent you certain question. Please take the third question and read it. A company wanted to invest rupees 60 million in plant and machinery required for its new industrial project. The company plans to borrow this money from its bank at the prevailing lending interest rate 18% per annum. 60 million, they want to invest at an interest rate of, they want to borrow this from their bank at an interest rate of 18%. The lifetime of the plant and machinery has been estimated as 12 years. However, the company plans to sell it after 5 years of operation. After 5 years, they want to sell it. For a value of rupees 24 million. It is estimated that the project will bring a net cash flow of rupees 15 million each year during the first 5 years of operation. 5 years of operation. Apply discounted cash flow, and justify whether the proposed new investment is beneficial to the company. Discounting tables will not be provided. You may use ordinary calculators, ordinary numerical calculators for this purpose. So this is the question. So company want to invest 60 million in a plant and new plant and machinery for a manufacturing purpose. The machinery has a longer period, lifetime, but anyway, they want to sell it after 5 years for a value of 24 million. And each year, the production activity will bring a net cash flow of 15 million. Net cash flow means the operational expenditure. You deduct the operational expenditure from the cash income, then you will get the net cash flow. Okay. So for this one, we will have a cash flow. We will project a cash flow for the investment analysis. The cash flow almost everything is same, but here we simplify this cash flow. We simplify this cash flow for the investment analysis. So we call it cash flow for investment analysis. Cash flow for investment analysis. Since the figures are mentioned in million, here we will say we have to mention rupees million. Rupees million. Then project years. Year 0, that is now. So in this one, we take it as year 0 means now. From now, after 12 months, it is year 1, over, year 2, year 3, year 4, year 5, year 6. Up to 5 years only, they have given the production. Right. The project years we have mentioned. Now, the income. So that is net cash flow from production activity. Net cash flow from production. Year 0, no. Year 1. So 12 months period. From today, 12 months period. 15 million. Each year they estimated 15 million. 15 million. Okay. Then they investment on machinery. Now they are investing 60 million. So this is cash outflow. This one cash inflow. This one cash inflow. This is cash outflow. So within bracket. There is another income also, that is sale price of machinery after 5 years. This is another income. Actually, up to 5 years, the machinery has to work, do the production. So, some people in this type of sale, some people take that the after sale value, after production, in the 5th year. Some people, but we, the World Bank, take it is after the 5th year. So, that is 24 million in the 6th year. Now, the net cash flow for the investment analysis. Right. So 60 million, negative, 15 million, 15 million, 15 million, 15 million, 15 million, 24 million. This much they are getting. So this one is 15 million plus this 24 million, all inflows. This 60 million is outflow. But we can't parabu. We have 15 million, 15 million, 15 million, 15 million, 15 million, 30, 45, 60, 75 plus 24. Here it is 5 into 15, 75 million plus 24 million. 75 plus 20, 95 plus 4, 99 million they are getting. They are investing only 60 million. They are investing only 60 million. After investing 60 million, over a period of 5 years plus the sale value of the machinery after that, they are getting 99 million. Oh, good. Yes, very good. People will say very good. By investing 60 million, they are getting 99 million. But we see whether it is worthy. Whether these future values, these are all future values, whether it is really worthy than this 60 million investment. And they are borrowing at 18% interest. So what we had to do is, they are borrowing at 18% interest. We bring these values, all these values, to the present value at a discounting rate of 18% because they are borrowing at 18%. They are borrowing at 18%. They are borrowing at 18%. We bring this value to the present value. Same present value, that is present value now. So it is same, we are bringing to the same value at 18% interest per annum. At 18% interest rate per annum. And after bringing, if it is more than 60 million, it is worthy. After bringing, if it is more than 60 million, yes, because this also a present value. This also we have brought to present value. So this present value, if it is more than this present value, then it is worthy. If it is not more, then it is not worthy. So let's just do the calculation. The steps are important. This is a normal cash flow. The normal cash flow for the investment analysis, the net cash flow for investment analysis. Right now, we bring all these values to the present value. So the step is important. Present value of the cash flow at a discounting rate of 18% per annum. Present value of the cash flow. So this present value of the cash flow at a discounting rate of 18%. 18% yes. So now discounting. So discounting factor. So before that one, we have to do it. Erasing PV. What we had to do, we had to calculate the discounting factor. So we write like that. Discounting factor of the cash flow at 18% per annum. Discounting factor. So first we have to calculate discount. I have already told you to calculate the discounting factor and multiply the future value to get the present value. Right. So here 1 divided by 1.1 plus 0.18 to the power 0. Yeah, now Actually, now 1 rupee is 1 rupee. Now 60 million is 60 million. Then here 1 divided by 1 plus 0.18 to the power 1. Here 1 divided by 1 plus 0.18 to the power 2. Here 1 divided by 1 plus 0.18 to the power 3. Here 1 divided by 1 plus 0.18 to the power 4. Here 1 divided by 1 plus 0.18 to the power 5. Here 1 divided by 1 plus 0.18 to the power 6. So we are calculating the discounting factor of the cash flow. Discounting factor of the cash flow at 18% per annum. So now this is equal to 1 divided by 1 plus 0.1, that is 1. So that is 1. Now it is 1. The next one. Again the calculator. Now this calculator here, compounding factor, equal sign, getting multiplied. Now divide. When you do the division, equal sign, it will get divide. Again divide. So here it is 1 divided by 1 plus 0.18. Here 1 divided by 1 plus 0.18. Again divided by 1 plus 0.18. Why? 1 plus 0.18 to the power 2. So there are 2. 1 plus 0.18 into 1 plus 0.18. That means 1 here 1 divided by 1 plus 0.18. Again 1 plus 0.18. Here it is 1 divided by 1 plus 0.18. Again 1 plus 0.18. Again 1 plus 0.18. It goes on like that. So in the simple calculator, when you put here it is 1, when 1 divided by 1 divided by 1 plus 0.18. That is 1.18. This is equal to 1 divided by 1.18. 1.18. Right. So I am raising it. So in this simple calculator, 1 divided by 1.18 equal sign. So here you will get 0.847. Now this answer should be again divided by 1 plus 0.18. That is 1.19. We print again equal sign. Again divide. 0.718. So this answer should be divided again by 1 plus 0.18. Equal sign. 0.6. 0.86 in the Nisa, 609. I will put 609. So this answer should be again divided by 1 plus 0.18. I press 0. 0.158. This answer should be again divided by 1 plus 0.19. I press equal sign. 0.437. This answer should be again divided by 1 plus 0.18. I press equal sign. 0.370. This is the discounting factor. So discounting factor with the simple calculator we have found out. This is the discounting factor. Now what we had to do, we have to convert this cash flow into the PV, present value. These are all future values. We now convert into present value. So that means you multiply these future values by the respective discounting factor. Multiply these future values by the respective discounting factor. Right. So now the step. Now the PV. We are going to convert these future value into present value. So the PV of the cash flow. PV of the cash flow at 18% PA discounting rate. And because then the discounting rate, Wednesday na potama, discounting factor also Wednesday. So you have to mention what is the discounting rate. So PV of the cash flow at 18% discounting rate. Discounting rate. So multiply. So multiply 15 by 0.847, multiply 15 by 0.718, respective discounting factor. So here it is 1, so it is 60 minus. All these are going to be the present value now. Now we have converted, all these are going to be present value. So 15 into 0.847, 0.847, 12.705. 12.705. Again 15 into 0.718, 0.718, 10.77. Again 15 into 0.609, 0.609, 9.135. Again 15 into 0.158, 0.158, 2.37.
So it should be 0.516.
Sorry. Yeah, 15 into 0.609, 0.609, 9.135. This is okay.
Next one.
Is it okay, no?
Yeah, that's correct. The next one.
Yeah. Now, next one, 15 into
516.
Oh, here this is wrong, no? Okay, I'll redo this one. 1 divided by 1.18. This is 4 here. So 1 time, 2 time, 3 time, 4 time, 515. Sorry. This 518. Sorry. 518. Okay? Right. That is 518. There was a small mistake calculation. So I corrected it. The discounting factor here 518. Okay? Right. 15 into 0.518. Discounting factor 7.77. Now 15 into 0.437, 0.437, 6.556, that is 6.555. And finally 24 into 0.370. 8.88. Now all these are the present values. we have converted all these to the all future values into the present value. All these are in the same platform, present value. So now we can total. We can total it, add or subtract. We can do it. Okay. Now we add all these things and see. These are positive values. This is the negative value. This is outflow. All these are inflows in the present value. All these are inflows in the present value. This one is the outflow. Right. Total it. 12.708 plus 10.77 plus 9.135 plus 7.77 plus 6.555 plus 8.888. 55.826. This is plus 55.826. This is plus. What has happened now? The income, the inflow in the present value is less than the outflow in the present value. Present value of the outflow is more than the present value of the inflow. So this inflow is not covering the investment in present values. When you analyze in present value, the inflow is not covering the outflow. So it is not worthy. This project is not worthy. So when we are looking at, oh my God, 99 million, it is coming. 60 million is only we are investing. 99 million is coming. So when we do it, it is not. So now the inflow minus outflow in present value, but it is a net value. So we call it net present value. Net present value. Inflow and outflow, the net. So we call it net present value NPV. Net present value of the discounted cash flow. At 18% discounting rate. That is equal to minus 4.174. Minus 4.174. So we call it net present value. So we are converting into present value, all future values, and then all are in the same platform, all are at the same level. Outflow as well as inflow, all are in the same flow. So you will net it. You will net it. So that is net present value, NPV of the discounted cash flow. This cash flow is the discounted cash flow. So what do you mean by discounted cash flow? The normal cash flow, when you apply the discounting rate, when you apply the discounting rate and convert all the future values into the present value, then that cash flow is called as discounted cash flow. So what we have done, this is the discounted cash flow. So when the meaning of discounted cash flow, when you apply the discounting rate to a cash flow and convert all the present or the future values into present value, then that cash flow is called as discounted cash flow. In a discounted cash flow, the net value of all outflowing and inflowing is the net present value. In the discounted cash flow, all the outflows and inflows, the present value, the net of present value is called as net present value. If the net present value is positive, that project is worthy because inflows are more than the outflows in present values. Once again, if the NPV is positive, then the project is worthy because the inflows are more than the outflows in the present value. That is, the inflow covers the investment in the present value. Then it is worthy. Otherwise, it is not worthy. So this is the cash. Only thing, you will get questions like this. Either the theory question you may get, or a problem like this you may get into exam. So theory question may be like this. Please explain the following: present value and the future value, compounding, compounding rate, compounding factor, discounting, discounting rate, discounting factor, discounted cash flow. Similarly, you may get the theory question. There are some more things we are going to learn now. You may get, or you may get a problem like this. Apply net present value and find out whether this project is worthy. So you have to do the calculation. I hope it is clear to everyone. Okay, now it is like this. So we get the net present value NPV minus 4.174 at 18% interest rate. So they do the company, they calculated, their financial analyst has done the calculation, told no, it is not worthy at this interest rate. So they are negotiating with the bank to reduce the interest rate. Okay, now the bank has agreed to give it at 13% interest. Yes. Now, the bank has agreed to give the facility at 13% interest rate. So, at 13% interest rate, whether it is worthy, let us do the calculation at 13% interest. We keep this one at 18%. At 18% per annum, it is 4 minus 4.174, 4.174. Now we do it at 13% interest. Whether it is worth. Yeah, please do it to yourself. So again now, discounting factor at 13% interest rate. After that, PV of the cash flow at 13% interest rate. Now everything we have to do it at 13%. The NPV of the discounted cash flow at 13%. 13%. So here now, discounting factor 1 divided by 1 plus R, that is 0.13. Here 0, that is 0. Here 1 divided by 1 plus 0.13. Here 1 divided by 1 plus 0.13 to the power 2. Here 1 divided by 1 plus 0.13 to the power 3. 1 divided by 1 plus 1 divided by 1 plus 0.13 to the power 4. 1 divided by 1 plus 0.13 to the power 5. 1 divided by 1 plus 0.13 to the power 6. This is a discounting factor. Discounting factor. So, PV of the cash flow. So, this is equal to, again, right. So, we simplify this one. Here, this is 1, discounting factor is 1. Here, 1 divided by 1.13. 1 divided by 1.13. 0.8849. So I say 5. Again, divide by 1.13. So 0.783. Again, divided by 1.13. I plus equal sign. 0.693. Again divided by 1.13. So I press equal sign. 0.613. Again divided by 1.13. So I press equal sign. 0.5427. So I say 3. Again divided by 1.13. So I press equal sign. 0.480. So this is the discounting fact at 13% interest rate. Discounting rate. This is the discounting factor at 13% discounting rate for the interest rate. So how much? Now we have something. So now multiply the discounting factor, multiply the future values by the respective discounting factor. Now multiply the future values by the respective discounting factor to convert that future value into the present value. So this is PV of the cash flow at 13%. The sentence is important. So this is 61 into 6. Now 15 million into 0.885 equal sign 13.275. Right. Now multiply 15 by 0.783. 11.745. Now multiply 15 by 0.693. 10.395. Multiply 15 by 0.613. 9.195. Multiply 15 by 0.543. 8.145. Now multiply 24 by 0.480. Sorry. 0.480. 11.52. Well, now everything in the same platform. All are the present values. All future values have been converted to present value. Sorry, this is negative. This 60 is negative. Yeah. Outflow negative. Now we calculate this one. Total income. These are all our inflows. Its present value. Total income 13.275 plus 11.745 plus 10.395 plus 9.195 plus 8.145 plus 11.52, 64.275. This is plus. Yes, now it is more than the outflow. Outflow is at present value 60 million. Total inflow at present value is 24.27. So the net present value, net of all these present values, net of all these present values at 13% discounting rate is 64.275 minus 60 million, 4.275 plus. So now at 13%, if they can borrow, then the project is worthy. 13% if they can borrow, then the project is worthy. Because the NPV is positive. NPV is positive. That means when we say NPV is positive, that is the inflows at present value is more than the outflow at present value. Then the project is worthy. So if they can borrow at 13%, the project is worthy for the company. Okay, well, now the time is 10:30. We will have a 15 minutes break and we will meet by 10:45. Thank you. We meet by 10:45. Okay. Shall we? Yeah, let us resume our working now. We continue now. Now, so at 18% interest rate, it was negative. The NPV was negative at 18% interest rate. It was minus 4.174. When the interest rate is reduced to 13%, it becomes positive, and the investment at that interest rate, it is worthy. It comes plus 4.275. I will make a note there. So at 13% interest rate, it is 4.275. Okay, now I will erase this one. You all have, I hope you have noted. I am erasing this. One thing, when you do this problem for your exams, you must mention cash flow for investment analysis, financial investment analysis, cash flow for financial investment analysis. Then you must say whether it is rupees million or rupees thousands, what currency you must mention. Or rupees thousands, or rupees million, you have to mention. Otherwise, the mark will be interrupted. And then all these steps should come. All these steps should come very clearly. That is very important. Right. I'm erasing this. Right. So now, you understand 18% per annum. Maybe this is interest rate. This is NPV. 4.17, 4.174 negative. At 13%, it is positive 4.275. So from 18, it is negative. When the interest rate is reduced, it becomes positive. It becomes positive. So in between these two interest rates, at some point, the NPV may be zero, because from negative, it becomes positive. 4.175, maybe 3 point, then 2 point, then 1 point, then 0, then +1, +2. So in between, at certain point, the NPV may be zero. At what interest rate the NPV becomes zero? At what interest rate the NPV becomes zero? The zero is a break-even point in this investment. The zero is going to be a break-even point in this investment. So if we plot a graph, so here in between, NPV becomes zero. Plot a graph. Here the NPV, this axis. Here it is positive value, here it is negative values. This may be zero. Then this is the NPV. This is the discounting rate, because the variables, interest rate, the discounting rate, interest rate or the discounting rate. discounting rate. Discounting rate. So variables are the discounting rate and the NPV. So we plot the graph. So say the graph is 13 to 18%. So let us say here it was 12%, discounting rate, 13%, 14%, 15%, 16%, 17%, 18%, 19%, it goes on like that discounting rate. At 13%, it is positive. So maybe somewhere here. 13% it is positive. And 18% it is negative, NPV is negative. 13% NPV is positive, somewhere there maybe. 18% it is negative. Somewhere. So in between, if you plot graph, you do this calculation again and again, 3 or 4 or 5 times this calculation by changing the discounting rate from 13% to 14%, 14%, 15%, 16%, 17%, 18%. When you do, you get that graph that you may get. You can plot the graph. Then you may go like that. You go like that. So at one point it cut the discounting. At one point it cut the discounting. That axis will be cut one point. At that point the NPV is 0. That point the NPV is 0. That is, at that discounting rate, NPV is neither positive nor negative. It is 0. At that discounting rate, the NPV is neither positive nor negative. It is 0. That one we call it as internal rate of return, IRR. Internal rate. So what is internal rate of return? Internal rate of return is the discounting rate of an investment, where the NPV is neither positive nor negative. Neither positive nor negative, the NPV. That is the internal rate of return. So IRR is the discounting rate of an investment where the NPV is neither positive nor negative. That is IRR, internal rate of return. Since we are doing all these calculations on financial basis by using the market prices, the cash flow, inflow, outflow, all those prices and all those values, market prices. We call it FIRR, financial internal rate of rate of return, FIR. Since we are doing all these calculations based on market prices, we call it financial internal return. There is another calculation doing this calculation on economic prices. When you do this calculation based on economic prices, that will be economic internal rate of return. Economic internal rate of return, EIRR. EIRR. Economic internal rate of return. So in this program, we don't do EIRR, only FIRR. Only we are doing FIRR. So this is FIRR. Financial internal rate of return. So when you plot, so internal rate of return is the discounting rate where the NPV is neither positive nor negative. That is the okay. So by plotting the graph also, so for that you have to do the calculations. You have to do the calculation about 4 or 5 times for you to get the points. And then you plot the graph and you can find out the IRR. But there is a formula, by using that one, you can calculate the IRR. We go to that one next. How to calculate the IRR by using the formula. I'm raising it. It's all clear, I hope. Financial internal rate of return. Very carefully listen to this formula. Carefully listen to me. I'm writing this formula. IRR is equal to lowest discount rate plus. So here in this example, 13% is the lowest discount rate plus difference between two discounts rate. Here it is 13% plus difference between two discount rates. So 18% and 13%, that is 5. That is 5. Difference between two discounts. Then into over bracket. NPV of the discounted cash flow at the lowest discount rate. NPV of the discounted cash flow at the lowest interest rate. So in this example, lowest discount rate plus 4.275 plus 4.275 in this example, divided by sum of the NPVs. Sum of the NPVs of the discounted cash flow. Sum of the NPVs. Sum means total. Sum means total. Sum of the NPVs at two different discount rates. two different discount rates. So here, sum. First one 4.174, second one 4.275. But the problem is, first one is negative, right? 4.174, second one plus 4.275. So when you total, what will happen? One is negative, one is positive. It may get subtracted. It may say subtracted. Then it is wrong. So what we have to do? Take the total. Ignore the signs. Ignore the signs within bracket. So take the total, take the sum, ignoring the signs. Negative plus you take the total. And bracket close. This is the one. So here 13 plus 5 into, I am writing it separately. Is equal to 13 plus 5 into bracket NPV of the discounted cash flow at the lowest discount rate, that is lowest discount rate 13% for 4.275 divided by sum of the NPVs of the cash flow, the discounted cash flow at two different discount rates. Ignore the signs. So, may signs ignore karna. 5 plus 4, 9. 8. 8.449. You will get this. 8.449. So when you solve this, this is equal to, and writing here, this is equal to 13 plus 5 into 4.275 divided by 4.275 divided by 4.275 divided by 8.449. 0.505. 0.505. So that is equal to 13 plus 5 into 0.505. 2.525. 2.525 is equal to 2.525 into plus 13. 15.525. This is the discount rate, IRR, where the NPV is 0. Where the NPV is 0. When you do this calculation, you know, when you solve this formula, first you do within the bracket. Within the bracket, multiplication. Then the division, then outside. So sometimes people, they 13 plus 5 multiply. Sometimes they add 13 plus 5 and then multiply. First you solve within the bracket. We solve within the bracket. We got 0.505. Then multiply that one by 5. We multiply 5. You got 2.525. Then go add on. So 13. The answer 15.525. So really, right? Yeah. So really, here between 18% and between 13%, it is 15.525, where the NPV is 0. This is the IRR. 15.525. Where the NPV is 0. IRR. So IRR, I have already told you, IRR is the discounting rate of an investment where the NPV is neither positive, neither negative. Neither positive nor negative. So that means if you are borrowing for an investment, you must borrow at a rate, interest rate below the IRR. Then only it is worthy. So your borrowing rate should be below this one. Your borrowing rate, if it is more than IRR, the project is not worthy. It is not worthy. If it is below, it is worthy. So IRR will decide which rate it is worthy to borrow. IRR of an investment will tell us at what rate you have to borrow for your investment for the project to be worthy. So that is the IRR. So now we have learned about the IRR also. We have learned about the IRR also. I hope everything is clear. So this is the formula, IRR, lowest discount rate plus difference between two discount rates. Then bracket NPV of the discounted cash flow at the lowest discount rate divided by sum of the NPVs of the cash flows. You can put it right. NPVs, this is cash flow of the discounted cash flow, at two different discount rates. Ignore the signs. Ignore the signs. Signs ignore. Otherwise, you won't get the answer. Otherwise, you will get answer at a very big rate. That is wrong. That will be wrong. So ignore the signs. Okay. So I will erase this one. I hope it is clear to you all. Right. Now, so when you do this analysis, first of course, I told you, you better have the normal cash flow for investment analysis. So where you will have the inflow, then outflow, then the net flow. So net flow, the normal net flow. So then project year 1, 2, 3, sorry, 0. We let us start from 0. Here 0, 1, 2, 3, 4, 5. It goes on like that. Here 0 it is investment, negative. Then here 1 will get income. Here the income, net flow or whatever it is, you will get it right. You will have the cash flow. Cash flow for the investment analysis. Then only we are going for the discounted cash flow. Then only we are discounting this cash flow. then only we are discounting this cash flow. And we call it as a discounted cash flow. Right. So without going for the discounted cash flow, from this cash flow for the investment analysis, by using the computer, you can calculate the NPV, IRR. Now only I am telling you, otherwise you won't understand what it is. So now you know what to do in your day-to-day banking work if you have to calculate the IRR or the NPV. The way we have done all these calculations up to now, you no need to do it. Through the computer, you can calculate it. But now you know what is NPV, what is IRR, how to calculate manually IRR, how to calculate manually NPV, you know. So now you can go and use the computer to calculate. So before that, you must add this cash flow. Net flow, you must add the net flow. Then Excel program. I hope you all have done the Excel program. There are so many versions. The versions to versions, certain formula will differ, but I am telling you only one version. Similarly, if you have different version, you can learn it yourself. Excel, you can learn it. Right. So Excel spreadsheet, you all know. There are cells. Excel spreadsheet. Take the cursor to a spreadsheet or cell. Take your computer's cursor to a cell. Maybe this is the cell. Right. Excel. Put an equal sign, and then put an NPV. And then bracket. Computer will prompt you. Computer will tell you what to do. Computer will tell you what to do. So what you have to do is you put the bracket and the NPV. So you want to do the NPV calculation in the brackets, and the computer will tell you first range. Computer will ask you for a range. So what is range? This is the range. So computer will tell you range. Take the cursor here. Take the cursor here. Anchor it. Otherwise, when you move the cursor just move. Anchor it here and highlight. Anchor it here and highlight. From here to here. Highlight. And put a comma. So the comma will come. Cursor will come here. So highlight. This is highlighted. When you put a comma, the cursor will come. Then you put the discount rate. What is the discount rate you are going to discount? Discount rate. Bracket close. And enter. You will get the NPV. You will get the NPV. Once again, take the cursor to your Excel cell, put an equal sign, type NPV, put a bracket, then the computer will tell you what to do. Computer asks you for a range. Range in the sense, the range of the cash flow. That is from negative, from all the positives of the cash flow. You take the cursor there, anchor it, and highlight. Up to the full range, highlight, put a comma, cursor will come here, and then the discount rate. You have to put the discount rate, whether it is 18% or 13% or 19%, but in decimal. If it is 18%, 0.19. If it is 12%, 0.12. If it is 10%, 0.1. If it is 9%, 0.09. You put it. No, sorry. If it is 9%, 0.9. Yes, 0.9. Then enter it. You will get the answer NPV. Sometimes when you do manually, you get the answer. When you use the computer, there may be slight difference. By decimal, because of the decimal, the computer answer will be more accurate than you may do it with 2 or 3 decimals. So computer answer, there may be slight difference will be there. This is NPV. Similarly, IRR, the range, you must have the range. You must have the range. Yeah, take the cursor to the cell of the Excel sheet, equal sign, then IRR. And then bracket, computer will prompt you for the range. Take the cursor, anchor it, highlight it, comma, range. Yeah, this is slightly different. Computer will ask you, suggest a rate. Suggest a rate. SUGG, suggest a rate. Whatever. The computer will ask you to tell some rate. So you put any rate, maybe 1%, 0.01 or 0.09 or 0.5 or 0.2, 0.4 decimal rate. You put any rate and enter. You will get the IRR. You will get the IRR. So here the computer will ask you suggest a rate, some rate. So these are the basic things, but from the version to version, Excel version to version, there may be slight changes. Excel version to version, there may be slight. So without doing all these calculations, what we have done, you will get the NPV or the IRR for a range, for a cash flow, normal investment analysis cash flow, you will get the answer by using the computer. Okay, right. I am raising it. Take the fourth question. Please take the fourth question. This is the theory part of the question, theory. So you may get theory or problem, both. Yeah, either one you will get. What would you understand by the following in regard to financial investment appraisal? We call it financial investment appraisal or analysis of a project. What you understand? Few explanatory sentences for each item would be sufficient. So you don't need to write a lot. A few explanatory sentences to show us that you understand. To show us you understand is enough. And wherever possible, give examples. So you have to give example wherever possible. 1. Time value of money, present value PV, and future value FE. We have explained. I hope you all understand. You can write in an exam paper. Discounting rate, discounting factor, discounted cash flow. The marks also we have given. How many marks will be given for? So this is we have learned today. Then net present value of a project and of a projected cash flow and its interpretation. NPV, what is the meaning of NPV? If it is positive, what? If it is negative, what? Why it is positive, why it is negative? So interpretation. Then internal rate of return of a projected cash flow and its interpretation. IRR? Yes. Interpretation. What do you mean by IRR? We have learned now. And its interpretation. What does it mean? Then calculating IRR using Excel computer application. We have learned now. Similarly, NPV, calculating NPV by using the Excel application program, computer program. So if there is a question, you all can answer, I hope. So you may get either theory question like this or a problem like what we have done. Right. Yeah, now we better do the last question. We better do the last question, that is number 5. Please, you better do it yourself. You better do it yourself. First, you read the question. Right. So this is a plastic company, ABC. They want to increase their production, so they are purchasing two machines. Blow molding machine. Plastic machines, there are two types of technology they are using. One is blow molding, another one is injector molding. Two types of technologies, plastic manufacturing. So one is blow molding, another one is injector molding. So they are purchasing two machines at a cost of 8 million. Then they actually installation of the machine. They are spending money, installation, and then training the people in the new machine. They have to train the people, and then test run at least about 2 weeks or 3 weeks. They must test it whether the machine is working properly. So test running. So these are also investment. These are also investment. They are spending. They are also outflow, investment. Right. That is 5 million, 500,000. So that is, we are doing all these calculations on rupees million. Rupees million. This is in rupees million. Rupees million. This is also important you must mention. Then, right. Then they are making about annually 150,000 units they are making from both machines, 150,000 units. From each machine, the net cash flow they are getting 25 rupees. That is all the income minus raw material cost, labor cost. So after reducing all those things, net cash flow from each unit, they are getting 25 rupees. So annually, from 150,000 units, they are getting 3.75 million. That is the inflow, cash inflow, 3.75 million each year. So 3.75. This is the net cash flow from the operation. 3.75. 1, 2, 3, 4, 5. Then the investment outflow, 8 billion on the machinery. That is during year zero. Then the training of staff, test running, installation charges, 0.5 million, 500,000. Then the working capital. Working capital also investment. It's a long-term investment. Working capital in a business is a long-term investment. As long as the business is going on, as long as the production is going on, as long as the manufacturing is going on, working capital will be there. It will be rotating, revolving within the business. So it is a permanent long-term investment, the working capital. 3.5 million negative. But this machine can work for 5 years. Then after that, they have estimated it has a residual value of 1 million. So they can sell the machine for 1 million after 5th year. So in the 6th year, once the production is everything over till the end of 5th year, at the beginning of the 6th year, they can sell for 1 million. At the same time, this 3.5 million working capital is also revolving. At the end, you can recover that working capital back. You can recover. So 3.5 million working capital also, working capital recovery. This is inflow. This 1 million is inflow. This 3.5 million is inflow. Okay. So now we have worked out the cash flow. Normal cash flow for the investment analysis we have worked out. So now the net cash flow is year 0, 12 million negative outflow, then 3.7 million inflow, 3.75 million inflow. Finally, 6th year, 4.5 million inflow. So now this is the cash flow. This one you are going to convert into a discounted cash flow. You are going to do the discounting on this net cash flow. So they are planning to borrow this at 14% per annum. From a bank, 14% per annum. So now you work out. Discount it with that 14%. See what will happen. So First one, but we have to do discount factor. Discount factor of the cash flow at a discounting rate of 14% per annum. Discount. So here 1 divided by 1 plus 0.14 to the power 0. So discounting factor. Discounting factor. Okay, now 1 divided by 1 plus 0.14 to the power 1. 1 divided by 1 plus 0.14 to the power 2. 1 divided by 1 plus 0.14 to the power 3. 1 divided by 1 plus 0.14 to the power 4. 1 divided by 1 plus 0.14 to the power 5. 1 divided by 1 plus 0.14 to the power 6. So now this is equal to discounting factor. Using the normal calculator. Yes, I have the normal calculator now. One divided by 1 plus 0.14, so 1.14. So here 0 it is 1, here 0 it is 1, now 1 rupee is 1. So then 0.877 in the year 1. Yeah, year 2, 0.769, 0.769. Then year 3, 0.64, 0.6. Seven, 49, I put it as 5, and again equal sign, 0.592, 592, again equal sign, 0.519, again equal sign, 0.455, I make it as 6. Right. This is the discounting factor at 14% per annum. So now we must convert these future values into present value. We must convert all these are future values into present value by multiplying these future values by the discounting factor. By multiplying the future values by the discounting factor. So the sentence PVs of the discounted cash flow, PVs of the discounted cash flow at a discount rate of 14% PA. So now PVs converted into PVs. So that is equal to multiply by the. So this is 12, 0 because 1 multiply by 12. Now other thing 3.75 into 0.877, 877. No, 3.75 into 0.877. 3.2887, so I make it as 9. Then 0.769, 0.769 multiplied by 0.769, 2.883, then 3.75 multiplied by 0.675, 0.675, 2.531, and 3.75 multiplied by 0.592, 2.22, 3.7975 multiplied by 0.519, 1.946, I make it as, yes, 1.946, 1.946. Now 4.5 multiplied by 4.5 multiplied by 0.456, 0.456. That is the discounted factor. 2.052, 2.052. Now all future values have been brought to the present value. All have been brought to the present value. All are in the same platform. So this is equal to 12.0 within bracket. Now all others are all plus value plus. Now we total it up. All are PVs. We have converted to the present values. So 3.289 plus 3.289 plus 2.883 plus 2.531531 plus 2.22, okay, plus 1.946 plus 2.052 plus 14.921. 14.921. So this is possible. So now all are PVs. One is positive, that is inflow at PV at present value positive. Other one is outflow at present value positive. Now we make the net. So we call it net present value. NPV. NPV of the discounted cash flow at discount rate of 14% PA. So now 14.921 minus 12, it is 2.921 positive. So equal to plus 2.921. So NPV is positive. That means all inflows at present value cover the investment cost, cover all outflows. All inflows at present value covers the outflows. So it is beneficial at this interest rate. NPV. So here in this one, we have additional investment. One is the investment on machinery plus the investment on installation, that is also investment outflows. They are investing installation, training of staff, and test running, plus the working capital. Working capital also investment. So all these things we are considering. So in this case, the machinery, there is a residual value, and the working capital, yes, the recovery. At the end, when you closing the business, you are recovering that working capital. That is the inflow. So residual value is also inflow. The working capital recovery also in. We are taking. Right. Now you read the second question. Now you read the second question. Theory part, of course, you can answer. Even the other one also you can answer. I will erase this one. Okay, I will erase. So when you do the exam, the steps and everything is very important. Steps. So that will, then only I know that you understand. When you write the steps correctly, then only I know that you understand the subject. So the steps and everything is very important. And that what currency you are doing this calculation. Well, I hope you read the question. I'm not going to do this question, but I want to just explain certain things. Now, here are the inflows that income or the net flow from the operation, how much they are getting, is given for different years. Year 1 certain amount, year 2 certain amount, year 3 yes. That of course no problem. You can simply yes, you can use it. You understand that one. But one important thing, that the installation and machinery installation, test running, training the staff, that takes a period. That takes a period. So the project leaders, year 0, that is now what we are doing. then year 1, year 2, year 3, year 4, year 5, year 6, it goes on. The year 0 can be 1 to 12 months. So, it is mentioned 4 years, the installation of the machine, test running, training of staff, everything takes a period of 4 months. So, year 0 in this case is 4 months. When the income comes, the year 1 starts. So some people, what they do, they calculate for 4 months and then again income for 6 months. Again, no, that is wrong. That is wrong. Year 0 can be from 1 to 12 months. 1 to 12 months can be. So in this case, it takes 4 months. That is year 0. Then the income comes from the year 1. Year 1. Okay. If you take this one for 6 months, balance as year for 8 months. If you take this one for 8 months, then all the periods should be on 8 months. All should be 8 months. The first year of income, if you are taking, say, about 8 months, then the balance period, or everything should be 8 months, 8 months, 8 months. Okay? So, because of that one, so year 0 can be 1 month, can be 2 months, can be 3 months, can be 4 months, yes, up to 12 months you can consider year 0. So in this case, it is no, as usual, you will be doing the year 0 is 4 months. Year 0 is 4 months. So the investment and everything coming in the year 0, that is 4 months only. And then year 1 starts. Year 1 is completely 12 months. Year 1 is completely 12 months. Year 2 completely 12 months. Year 3 completely 12 months. It will go on. If you think year 0 is 4 months, then the balance 8 months for the year 1, no. Then everything thereafter, everything you have to do it on 8 months basis. And your discounting rate also you have to do it for 8 months. Discounting rate you have to do it. Now, when you do it the computer analysis, computer doing for each month, because that is computer. Now we are doing manually, year by year we are doing it. The computer do it for each month doing it and give you the answer. Computer doing for each month and give you the answer. When we are doing manually, we are doing for each year. Okay, so that is the only information I have to give you from that. So if there is a question in future, don't get upset. If the installation, training, test running will take about 5 months or 6 months, if we mentioned, yeah, it is year 0. With that one, year 0 is over. Then the production income starts year 1. You consider year 1. And in this case, the year 0 is only 5 months or year 6 months. Only that. Okay. Hope you will understand. You understand everything. Right. And then another thing, assignment. About the assignment, we have given you about the pledge facilities and the trust receipt facility. You have to prepare the assignment. I hope you all would have read it. I think assignment, the period and everything is given. And you must, it's a type 1, you must prepare your assignment, is a type 1. Only 1 page should be typed. If you type both pages, then of course I will give you 0 marks. I can't help it. So only 1 page should be typed. So maximum, we have mentioned how many pages in the note. Of course, we have mentioned maximum. Don't exceed that one. Don't exceed it. So there are 2 things. One is pledge facilities, and another one is trust receipt facility. Read it carefully. What you have to mention in the assignment is given. So you don't need, you have to get those information and you have to put it. It is very clearly, it is very easy for you to do it. So only thing, this thing you can use it as your heading, subheading. We have given the definition. The definition as a subheading, you can go over. So we have given you about so many questions. Yeah. So those questions you can use it as a subheadings and prepare your assignment. The font size is very important. The font size, what font size, you have to read it and see. Yeah, you have to give all those things. And the deadline also given before that date. And references. So what and what things you have referred, you have to mention. If you discuss with your senior bankers, your superiors, yeah, please mention their name and their position and the institution under reference. Under reference, you have to mention. Okay. Yeah, if you have any doubt or anything, you can give me a call. You can give me a call. I have already given you my telephone number. So if you have any questions on this one, yes, in this one or what I told you today or all my subjects, what I have told all these days, yeah, you can give me questions and you can get it clarified. Assignment, please, you do it yourself. You do it yourself. You can discuss with your friends. You can discuss. Don't copy it. Don't copy. If we find that you have copied someone's assignment, then it is very bad for you. Okay, so don't copy it. Do it yourself, but better discuss. You have to discuss with your friends. What is this one? What is this one? You discuss and yes, write in your own English. Put it in your own English. Yes. Okay. Anyway, all the best. I think I may meet you once again. Again, only once I will meet you. Okay. Thank you very much. We close it now. Thank you. Thank you very much.